Hello, my name is Charlene Tshitoka. My Twitter handle is CharlieMole, and I work for a company called TES. For those of you who are here in the morning, my colleague was sitting somewhere there. Yeah, he did a talk on TES and how we do microservices and all the crazy. So I'm not going to talk about that today, but what I want to talk about is back pressure in Node.js and how I did find out about that. And what was my experience, because I actually did something and then I had to go and read about this. So I'll just share with you what I discovered, some of the things to watch for when you're doing some script in Node.js, and just the cool stuff to know if you find it cool, I guess. When you're about to write a script that's going to deal with lots of data. So this is my agenda. I'm just going to talk briefly about events and event emitter, what they are in Node.js specifically. Then I'll talk about the streams. Then I'll talk about back pressure, how it plays into this whole things of streams. We do a small demo, and then I'll tell you a quick summary of my learnings and what I think you could know. So to start with event emitters, the way I understood that is Node.js architecture is built around event-driven architecture, right? So you emit an event and something happened because that event happens. It was emitted. So I'd see events just like action, like close the door or open a HTTP request, or even open a file or change a color, ring a bell, right? So there is an action, and because an action was emitted, if there is a listener, if there is a handler that cares about that event, that decide then to do something based on the action. So the way you do with the listeners is that you attach the callbacks that are called only on demand. Demand meaning the event actually happened. And if these events never happen, if they're never emitted, then the listeners never get called. And lots of people here have talked about event emitter briefly and streams. Not going to go the details of that. But basically, in Node.js, there is a class called event emitter, and it allows you to do just that, to build instances where you can actually attach listener and you can trigger also events, right? So this is a very simple example, event emitter 101. I want to ring a bell, and every time they ring a bell, there's a visitor, and I've attached two listeners. One that will say, hey, if there was a visitor, say this is the visitor that ring the bell, and then the other one doesn't really care about the visitor. And you'll see the difference between the two is that the first one is using the on method, and the second one is using the once. So the once is a listener that only cares once. So once that's done, if I just listen to one single ring, and then I detach myself for the event. So that's basically it. So if you run this and you meet the ring, and both of them are going to say the first time, listener one will say, I heard the bell, but because you didn't send me the visitor, so you're just going to print, I heard the bell. And the listener two is going to say, I heard the bell too. But the second time you do that, and only the first one will actually say, listener one heard the bell from Zoe N. So, what are streams then? The streams in JavaScript are Node.js, I would say. They're just an instance of an event emitter. If you look at the way our code actually is, they emit specific type of events, and when you attach to them, you know exactly what events to look for. If you look at something like a read stream will emit on data, and I can say, okay, every time I hear data, then I want to do something. So the events mostly in JavaScript, in Node.js, they will just be string, and you use lowercase to name them, or uppercase syntax. And then when something happens on the data, for example, something will be listening, and it will say, okay, there was some data, and process them. Why would you want to use streams? The advantage of using streams is you are always processing data in a continuous way. When you think about data, and I'm not necessarily talking about like 10 lines, I'm talking about, let's say you have millions of records, in a file, like 27, God knows, gigabyte or 8 gigabyte file, like a huge file, lots of records. If you have to read that entire file into your memory, and you could actually, I will show you an example, exhaust all the memory. So the whole idea of streams is, hey, don't do that. Instead, create small chunks, then you're just gonna take them as they come and process them and go to the next one. So that's the big advantage you get of using streams. And you're doing that in the continuous way until you have processed all the chunks, and then you discard them. And the other thing that's important to know is you can have push versus pull stream. The way I think about it, Guy gave actually a very good example. So imagine you have a tap. You open a tap, you put a hose, and you put a basin. The water is coming from up, down, and it's going to keep coming unless you close the tap. And if you don't close the tap, the water will actually overflow in the basin, and then you will lose some water, right? So that's push stream. And pull stream is, I had my Coke, I have a Coke, and I have a pipe. And then I am the one actually pulling. When I feel that I have too much, I can stop. I have control, right? So I can decide never to get overwhelmed because I, the destination, deciding on the flow. And that's quite an important thing that Node.js added to the streams. And you'll see a reason why. I didn't know it, and I did something stupid, and then I had to go read the documentation, right? So my talk, most of what I'm going to say is around the pull stream and how we can actually utilize that power, the flexibility that Node.js gives you to do something useful. I'm good. So the type of streams. I've talked about the readable streams a lot already. So we have Node.js mainly has 4 types of them: the readable one, the writable, duplex, and transform. And the readable one, when the server receives a request, HTTP request, that's a read stream on the server. But on the client that actually said it was a write stream because the client put something on it, right? So the server just cares about reading it. And the opposite is true. When the server sends a response, it's actually doing a writable stream, but once it gets to the client, it becomes a readable stream. And you will see that I put TCP sockets on both sides because TCP socket is a duplex stream, right? You can read and write. You read from a source and write in destination. And the way Node.js does it is that it keeps 2 separate buffers because it doesn't want, imagine you are reading faster, which is true if you're reading from a very fast source, you can read faster than you're actually writing. So it's quite important that the 2 buffers are not together. So, and the last one, which is the transform stream, is actually a form of duplex stream where you, as you are reading data, you're doing some transformation on them right on the fly before you actually write it back. And this is quite cool because this is what saved my life. Not technically my life, but yeah, you know what I mean. So again, very basic, stream example. I have a file, the number of people, let's say, I don't know, 100,000 in that file. And as the chunks come, I just display the chunk size. And as you can see, I'm just displaying the chunk size. I don't really care about what is in the file, but we could display that. My size, these are all the different chunks that make up my file. So then when I'm reading the first time, it will take, and that's what the buffer that is configured to get at that time. So basically, it's going to read this file, get a bunch of data, then get another one, and then get a third one. So that's basically what it does. And then let's talk about types. When you have a stream, and you have another stream, let's say you have a read stream, and then you have a write stream, you can put the 2 together by creating a pipe. And when you create a pipe, you can make your stream change from being in a reading mode into in the writing mode. And you can pipe a bunch of streams. So in this example, I have a read stream, again, people, simple, and then I have a transform stream. Not doing anything crazy, I'm just really taking every bunch of data, converting it into uppercase, and then writing it back, right? So then I have the piping process. So if we had to run this, right? So you'll see that this is what is in my file, but then this, when I write this, this is what happened. So that's basically all I did there. And piping is a way, is what you can use to even do even more control into your data. So imagine that I have a source, super, super fast, or I even, let's take it easy, I have a very, very super fast, and I have a destination not as fast. What you can do with that and the power of transform stream is to say, as you read this data, I want to maybe slow it down a little bit because I know this can only handle that much data. And then you feed it into the thing. And back pressure is a very good way for you to control flow. And this is quite a powerful tool once you know, and the kind of problem, I'll talk about the kind of problem you could have and how you could solve it. Before I do that, I'll talk about what I didn't know, right? So all these things I just told you now, I read it after I made my mistake. So let's go from the beginning. 11 months ago, I joined TES, and a colleague flew from Cape Town, onboarding 3 days, and they say you're implementing your first feature. I was part of the social team by then. We could display the number of followers someone had on the site, but we were not saying how many people you were following. So you could see only your followers. So my main task, first task is like, display that. And I'm like, yeah, that's easy. Select this, and then my SQL turned out we were using Cassandra. Why? Don't ask me. And I thought I knew Node.js because I had done some JavaScript before. That was cool. I'm like, how difficult can it be? Right, JavaScript, whatever, and I implemented the feature. And then later on, I actually had to do a migration because we had this table. We had to read all the records, about 2 million, just a little under 2 million, and then replicate it into another table. And then for everything we read in the second table, we had to update the counter table. Those who have worked with Cassandra will know about the counter, right? So in Cassandra, I can't just say select count everything where follower is that, because Cassandra was not really made for that. So you actually need a counter table where you keep track of the counter every time it happens. So for every record that I inserted over here, I actually needed to then keep track and then update my counter table. So I say that's quite easy to do. I wrote the script, and I tested it, I promise you. In local, against development, in my Mac machine, and local, our development environment has only like about, what, 60,000 records? Not bad. I did it for each. For each, do that, boom, synchronous, update. It works. And then I go to Daniel, who's a colleague, and I say, hey, Daniel, I need a box to run this against production. And they say, cool, gave me a tiny box. And then we have, as I say, again, just less under 2 million, and I did my thing. And then this happened. And then it was like, we seem to be getting a lot of connections happening all at the same time, because I literally did for each, so I read all the record, for each callback, update here. Boom, literally broke the VM. So then I said, okay, I really thought this was doable. Ping, what happened? And then they say, that was not really smart. Did you think about back pressure? I'm like, what is that? I wrote the for each, there was a coolback. Can you get even cooler than that? So, to actually show you if it can get cooler than that, I'm not showing you the example of the actual production data, but I've created a replicate scenario where basically I have movies. In the Mongo collection, I have movies, and I've uploaded just about, I think, 1 million. I've generated another thing called runtime that had about 6,000. So a runtime is how long a movie takes. Because when we first created the collection, we didn't think about the runtime. Now they say, hey, we have 6,000 runtime, we want you to update that. But I also did another one that has exactly million, right? So we're going to do exactly what I did with, in this case, 6,000, but that was about 60. And then we're going to do the exact same thing with a million. And then we're going to see how we can go about fixing something like that. So I have nothing difficult, a function that accepts the file name, read the file sync. In that case, I read find all the records. And then for each of them, I'm doing an insert, an update in this case. So when I run this, right, 6,000, pretty fast. That's really cool. Okay, so then I have all of them. And then I was like, yeah, it's just, you know, a million, so it's taking some time, no big deal, it's going to complete eventually. Right? And yeah, so that happened. So that because, of course, this is bad, this. The first thing, download all your file, all your whatever it is, if it's all the records coming from a DB or coming from a file, download everything into memory, right? It's just bad. So create a stream. As I said, what the stream gives you is the ability to actually break your data into small chunks. And if you're using something like a read stream in this case, you can actually decide how big of a chunk you want. So then I say, okay, in my case, I'm reading from a file, and then I'm dating. This is going to work. Do you think it's going to work? Silent. Didn't. It worked for the first chunk, and thus it failed miserably. Second lesson, know your stream. On data doesn't guarantee to you, with the read stream, it doesn't guarantee to you that it's giving you one line. It's giving you a chunk. And what a chunk can mean is that it can give you 2 lines and then part of the 3rd line, which is not my entire full line. So this is what is happening. The first time it did it correctly. The second time it didn't actually provide the full chunk, and then everything just failed. Okay, obviously I'm not learning. So, my other lesson. Remember I talked about transforms in the beginning and how you could actually take advantage of it. So there are quite a number, and you can write the transform stream. In the example I did show you in the slide, transform stream, really all you need is to inherit, and then you need to call the constructor, and then override the transform method, boom, you're done. But if you don't want to do all that, there are quite a number of libraries that could do, if you know you're doing something specific and there's already a library for that, you can just npm library, you can just use it. In my case, I knew that to solve my problem, I needed every single line to be processed as it came. So all I did is I took my split, my stream, and I piped it with another one. So the split will always make sure that I get all my data in thing. And that worked. It worked just fine. Again, big transform stream. If you have to do something like that, because it's giving you one line of the time, it can take either a long time or long time. There is another stream, again, with library that we can use, where you can actually decide on what you want to do, how much I want to feed into my thing. Because obviously, I'm not really planning on running or starting a thing and then going home, sleep, and then getting a call in the middle of the night to say that it was broken. So I want it to be completed by the time I'm done. There is another stream that can help you do that. And that is this pressure stream. And I've come to really like this one. So the difference between what I showed you before and the pressure stream, I'm still splitting it one by line. Then I'm creating a pressure around my stream, and I'm saying, I want you to let in the very high, when you have too much data, do not go over than 80. And when you don't have that much data, then 50, not lower than 50. What I'm doing is I'm sending 50 or 80 at a time. And with doing that, I can actually update my movies without actually breaking anything. I'm showing time. So when I did that, with, again, a million record, you could see that now it didn't do that old boom memory extension. It's going it nicely. And one of the good ways to see about this, it didn't happen until later. So I was able to use the pressure stream, saved my job, but then, until one day a colleague pinged me and said, hey, Charlene, I'm trying to do something. So we had, because we have a lot of microservices, most of the time we communicate using RabbitMQ, right, so asynchronous. So the whole thing was updating this DB, and then we needed to publish a message so that the other system could also know the people that are listening and then update. So we basically taking from a DB, doing a DB update and sending a bunch of message. Again, she tried it into dev, and it worked, and then did it into production, and there were like 1,000 on messaging dead later. Two problems with that. The first one, we're talking about production. They're actual users trying to use their system at that time. So you trying to send, I don't know, a bunch of 1 million messages, or even 500 at the same time, is not cool, right? It's really not cool. So you don't want, because you're trying to run a migration in production, to actually feed too much data at the same time to your thing. And the second one is, if your queue is configured in such a way, and the other thing can happen, maybe it was too slow, maybe the buffer got too full, it's actually going to dead later. And if you don't have recovery config, God, I hope you have recovery config, you're going to lose a lot of data. And again, that's not cool, right? You put your system in an inconsistent way. So she wrote the script, she tried to run it, and then she got that memory thing nice. So when she talked to me about the problem, the first thing that came into my mind is like, I know, you need to put some pressure on the stream, right? So, and that was how I actually, so this is gonna complete, don't need to look at that. Oh. You know, time, cool, okay. So, let's say we want to do exactly what I told you. I have here, trying to read, I'll share this over my GitHub thing so you can download it if you want. But basically, the whole idea, I'm using Rascal, which is just a wrapper around RabbitMQ, and have some config here, nothing fancy. So then what I want to do is connect to the DB, create the broker, and then when I have data, just publish it. But there's something interesting about my queue, and this I did to simulate what kind of happened in production. I have this queue that can only have a max length of 5, right? So I'll say, okay, let's be smart about it and put the send time out and send the data as we got them. And then I have my 2 queue over here that we're going to watch. So this is my actual where I want the data to end up, and this is the dead later. Right? You can see that later. So, that's not what I want. Okay. Node, publish. Okay. refresh, and refresh. Can you see? This is my dead letter. I already have 143, and it keeps on growing. And if I come over here, and I look at my message rate, I'm getting about 500 per second. Not good. My queue cannot handle it, right? Why? Again, I didn't think about how do I actually control the flow. This is a case of a source where you're reading too fast and the destination can actually handle. So how can we solve this issue? So the way we solve this, let's just purge our above queue. Go back on top. It's going to purge. Is by putting some pressure. I know that on the highest, I can only handle 5. The lowest one, you could put it 4, it doesn't really matter. So I'm only making sure that I only send this much. And when I run my script, and I'm printing the counter just so you can see, that you're seeing that it's only making sure that it never exceeds that number. Sometimes it's like 1, 2, but it never exceeds 5. And when I look at my dead letter queue, you can see that my dead letter queue is empty, nothing dead letter. This is from the previous execution. It's just gone flat. And the nice thing is, I can now see that I'm only publishing 5 seconds. And this is how I ended some of the issue. So what am I trying to say here? Of course, streams is not the solution to every problem you have. But sometimes you'll have this kind of problem, where you're dealing with data where you have to migrate something from here over there. It could work if you do it locally and you feel pretty awesome about it. But when you have to deal with data in production, you have to start thinking about the impacts that you have on the customer. How many connections am I trying to open right here against this DB in production? You don't want to be doing that for a script that's for maintenance, opening I don't know how many against your production DB, unless you have lots of money and you have lots of resources right on your production. But you don't want to be doing that. The other thing is, what is the impact of what I am doing against the customer who's actually sitting and trying to get something done on the site? And this kind of thing should really dictate how you go about deciding on this thing. It really feels good to write this script, and Node.js gives you a lot of power, I tell you. And it feels really cool to have all those kind of power. But you have to really think carefully about, okay, with this much flexibility comes also a lot of responsibility. So what are the things that I can do to make sure that it doesn't happen? And when you if you ever have to deal with this kind of problem, you have to write a script or anything like that, think about streams and what they can provide you and the kind of flexibility that you get. Right? There are even other libraries where you can actually decide on the rate. Right? I only want this much per second, like 5 KB of data per second. And there are so many libraries in NPM that do that. I think there's something called break also. So just think about that and make sure that when you're implementing your solution, you have that in mind. So what did I talk about? Ooh, okay. So I talked about events, emitters, and streams, back pressure. When could you need back pressure? Obviously, it's not the solution to everything. And then, yeah. So that was me. Thank you. I think I'm 1 minute over time, so I won't take a lot of questions yet. That's a good question because I had to do another thing where we have to trigger a bunch of email. Every Monday we have to remind, for example, the people to go submit the shift. And the person who wrote the thing and then put the documentation, just play around with pressure and see how much you can handle. So I think that's the answer I'll give to you. Obviously, you have to understand what kind of data you're dealing with and how much you can handle. And again, that's not the only way to put on pressure. You could say, wait 1 minute before sending the next batch of data. A lot of things. You can write your own transform stream. Okay, I'm really out of time. Sorry, Kenneth. Thank you. You can ask me more questions later on, and I'll share the code.